Hello my dear friends, welcome to my YouTube channel MJ Makes Easy Edu Academy. And today I am here to discuss with you mathematics 10th class chapter, that is real numbers. So before entering to this topic, let me say you what concepts I am covering you in this topic. The first topic for you will be the basic concepts of real numbers. The second will be Euclid's division lemma, and third is the fundamental theorem of arithmetic, and the fourth is not the least the logs, the logarithms. Right, so let us start with the basic concepts of real numbers, that is natural numbers. So what is the first? That is what? Natural numbers. So what are natural numbers? What are natural numbers? It is denoted by n, and it starts from 1, 2, 3 and then so on up to infinity. We can call this natural numbers as counting numbers. What we can call? We can call this as what? Counting numbers. What you can call? Counting numbers. And the second is whole numbers. What is? Whole numbers. Denoted by capital W. It starts from 0, 1, 2, 3 and then so on. Right. So here in natural numbers and whole numbers, in whole numbers we also have 0, whereas natural number starts from 1. Right. Then coming to integers. I think you all know this, but even then, just to complete this, integers denoted by Z. So this integers have whole numbers, but this also has negative numbers. That is, it may be from -3, -2, -1, 0, 1, 2, 3 and then so on. And now the climax is what? That is rational numbers. What it is? What it is? It is what? It is rational numbers. Rational numbers. So denoted by Q, and it is in such a form, it is in the form of P by Q. So whenever any fraction, or it is in the form of P by Q, what is? It is in the form of P by Q, then it is a rational number. Any term which is in the form of P by Q is called as what? A rational number, but on one condition, that Q should not be equal to 0. What is the condition? Q should not be equal to 0. Got it? So I got examples as 2 by 3 in P by Q form, -5 by 10 in P by Q form, and -13 by -46 in P by Q form, etc. What I can write? Etc. But whereas if I take this Q, P by Q, if I take -13 by 0, then this is not a rational number. So what is the condition to satisfy rational number? The rational number, their Q value should not be equal to 0. So remember this. Got it? Right. So in this rational numbers, we will come to know about terminating decimals, non-terminating decimals. So I think you know about decimals which come in points. Right. So we shall discuss that, terminating, non-terminating, what is repeating, what is recurring, in the next topics. Ready? Okay. So please make a note. First let me write about terminating decimals. What you can write? Terminating decimals. Terminating decimals. It means it has end digits. What has a? It has end digits. Or we can say a remainder becomes 0. What you can say? remainder becomes 0. What you can say? Remainder becomes 0. So let us write one example. Ready? Okay. So let me take as 3 by 8. 3 by 8. So I can divide the normal division, I can do it. That is, if we take here 8 and divide this 3, so what we get? So 8 is bigger, 3 smaller, so 0 point. We take here 0. So 8 3s are 24. Am I right? Then here borrow, it is how much? 30 minus 24 is how much? It is 6. Got it? Then again, if I take 0, then 8 7s are 56. Then what is 60 minus 56? Is 4. Then again, if we take 0, then 8 5s are 40. 8 5s are 40. So here we are getting remainder as 0, and here it completes. It's stopping. It is a stopping. So this is one example of what? Terminating decimals. Got it? Then let's take one more example, that is 1 by 4. If I take 1 by 4, what it happens? Let's check. So 4 divided by 1, so it's 0 point, it's 0 here. So 4 2 ja 8, then answer is 2, and then it's 0, then 4 5 ja 20. So it's converting to what? 0, and it is also stopping here. So these type of decimals are called as terminating decimals, where the remainder reaches to 0, and here this question stops. Got it? Please make a note. Non-terminating decimals. So let me take one example, and let me take two examples and make you understand. Ready? Sure. First example, 5 by 3. So divide 3 with 5. So what we get? So 3 1s are 3. Am I right? Then here remainder is 2. Then 0.0. 3 6 are 18. Then how much is remainder? It's 2. Then again 0. 3 6 are 18. The remainder is 2. And here one more time. 3 6 are 18, and remainder is what? 2. In this way the fraction, in this way the division continues, and it is non-terminating. What it is? It is non-terminating, and what we can say here, remainder does not becomes 0. Remainder does not becomes 0. Understood, children? Here when we divide this normal division we are doing, so when we see here that remainder does not becomes 0, and we can write this value as 1.6 bar. This bar notation, this bar indicates that this value is repeating. This value is what? Repeating. Got it? Let's take one more example. For example, we can take one more, 3 by 7. Let us try 3 by 7. So 3 by 7, let us try. Okay. So it is 7 divided by 3. So how it is? So 0.074 are 28. Remainder is 2. Then again 0. 7 2s are 14. How much is remainder? Remainder is 6. Then 0. 7 8s are 56. Remainder is 4. Then again 0. 7 5s are 35. Remainder is how much? 5. Then again 0. Then 7 7s are 49. Remainder is 1. Then again 0. 7 1s are 7. Remainder is how much? 3. Then 0. Then 7 4s are 28. Remainder is how much? 2. Then again 0. What you can write here? 7 2s are 14. Remainder is how much? 6. Remainder is how much? 6. In this way the number continues. So these type of decimals are called as non-terminating decimals. What they are called? Non-terminating decimals. Hope you understood. So here you can find the number is repeating. Here it is repeating 1.666 and remainder is not terminating to 0. And here also you can see the remainder is not terminating to 0 and this is going on continuing. So these type of decimals are called as non-terminating decimals. What they are called? Non-terminating decimals. Okay, copy down. So next is non-terminating repeating decimals. What they are? Non-terminating repeating decimals. Non-terminating repeating decimals. So let us take first example, that is, okay, so 4 by 3 equals to 3 and then 4 is here. So 3 ones are 3. Remainder is how much? 1. What is the remainder? Remainder is how much? 1. Then I can take here as point and then 0. 3 3s are 9. Remainder is 1. Again 0 is here. Then 3 3s are 9. Remainder is how much? 1. Then 0 is here. Then 3 3s are 9. The remainder is how much? 1. 3 3s are 9. The remainder is 1. So here it is repeating. It is not terminating. It means it is not becoming 0. It is not becoming 0 and this number is going on repeating as 1.3333333 and so on. I can write this as 1.3 bar. What I can write? 1.3 bar. Right. 125 by 99. Let's try. Are you all ready? Are you trying? Come on, pause it and try. Okay, I am doing. So 125. So 99 ones are 99. How much it is? I think 260, 26, right? 26 is the balance, right? Then again, 0.0. So 99 into 2, 99 into 2. What do you get? 198. How much? 198. Am I right? Yes. Then again, how much we get here? 2. 15 to 9, it's 6, 0. Then again 0. Then 99 into 6, 6 and 54, 5, 54, 59, it's 594. How much it is? 99 into 6, 594. What do you get the value here? What do you get the value here? So 2, 6, how much we get here? 6, 11, 9, 10, 11, 2, 0, 260. Then again 0, 99, 2s are 198. Again it's 62. Again it's 0. Are you following up? Are you following? Then again 6 jar. How much it is? 594. How much it is? Again how much it is? 260. Am I right? And the remainder goes on continuing, giving as 2626. So I can write this answer as 1.26 bar. So in this way they are non-terminating and repeating decimals. What they are? Non-terminating or repeating decimals. And what values are repeating? They are also called as recurring decimals. What they are called? They are also called as what? Recurring decimals. Got it? Fine. Okay. Make a note. If we take pi value, pi if I take, we take as 22 by 7. If it's a very unique pi value. 7 divided by 22. What do you get? 7 3s are 21. So what we get? 1 is balance. 0.0. 7 1s are 7. How much it is? 3. Then 0. 7 4s are 28. Am I going correctly? Yes. 28. Then 2. Then how much it is? 0. 7 2s are 14. How much it is? 6. Am I right? Then 0. 7 8s are 56. Balance how much? 4. 0. 7 5s are 35. How much it is? 5. Then again 0. 7 7s are 49. How much it is? 1. So these type of decimals which are not terminating and not repeating. What they are? Not terminating and not repeating decimals. Pi value. Then coming to root 2 value and coming to root 3 value. What is root 2? 1.41442. Then what is this value? 1.732. 1.7321, what is 1396237. Then again root 3 value 05080, and then so on. In this way, these values are non-terminating and non-repeating. What they are? They are non-terminating and non-repeating decimals. So these type of fractions, they cannot be expressed. They cannot be expressed in P by Q form. What is that? They cannot be expressed in P by Q form, whereas other number, those can be expressed in P by Q form. So they are called rational numbers, and these type of numbers are called as irrational numbers. What they are called? They are called irrational numbers. The numbers which cannot be expressed in the form of P by Q are called as irrational numbers. And now I can define real numbers. That is, real numbers is denoted by R. It is the union of rational numbers and irrational numbers, where rational numbers is denoted by Q and Q dash is denoted for the irrational numbers. So what are real numbers? Denoted by R. It is a union of rational numbers and irrational numbers. Got it? Hope you have understood. A small Venn diagram. If you take this as area of a Venn diagram, okay, then if this is real numbers, then if this area is Q, that is real numbers, or getting as irrational numbers, and if this is Q, that is rational numbers. Inside rational numbers, what we have integers that has Z, and what we have whole numbers as W, we have natural numbers as what? N. Got it? So this complete union is called as what? Union is called real numbers. So here this Q dash is irrational number and Q is a rational number. Then again the integers are subset subset means what? The elements of Z can be found in Q, and whereas the whole number is a subset of integers. It means whole number elements are found out where? In integers. And whereas natural numbers are a subset of what? Whole numbers. It means all the elements of natural numbers are found in what? Whole numbers. So I can write as N is subset of W is subset of Z is subset of Q. Got it? So what is real number? Real numbers is the union of rational and irrational numbers. What is the ratio of what? It is a union of what? Rational and irrational numbers. Hope you have understood. Right. Let me say you small theorem. Okay, get ready. In rational number, there is P by Q form. Q is not equal to 0. Q is not equal to 0, but denominator Q is in the form of 2 to the power of m into 3 to the power of 5 to the power of n. Then it is terminating, or it is terminating. So make a note. So in rational number P by Q form, Q not equal to 0, the denominator Q is in the form of 2 to the power of m into 5 to the power of n. Then it is a terminating decimal. What is? It is a terminating decimal. If it is not in this form, then it is not a terminating decimal. So let me take one decimal and make you understand. It is 0.375. 0.375. I can write this 0.375 as 375 by 1000. How we write 1000 here? Because after 0.3 digits are there, I have taken 3 zeros. Got it? So I can simplify it as 5 200 ja, 5 sevens are 35, then 5 fives are 25. Am I right? Then 75 by 200, is it? Okay. Then again 5 15s are, 5 40s are, then 5 3s are, 5 8s are. How much is 3 by 8? And 8 we can write as 2 cube. Can I write 2 cube? I'll just write it like this: 2 into 2 into 2 equal to how much you can write? 3 by 2 to the power of 3. 2 cube. Can I write like this? Into 5 to the power of 0, where x to the power of 0 is equals to 1. Now is it in the form of 2 to the power of n, m into 5 to the power of n? Yes. So this type of decimals are called as terminating decimals. So by the denominator we can decide that this decimal is a terminating decimal. Let's take one more example. Okay, ready? Right. So 12.5. 12.5. So I can write this 12.5 as 125 by 10. Then this I can write this as 125. Denominator can be expressed as 2 into 5. It means it is 1 here. So what I can write? So this terminate is in the form of 2 to the power of m, 5 to the power of n. So this can be a terminating decimal. What is? This is a terminating decimal. What is? Terminating decimal. So if it is in this form, denominator is in this form, then it is a terminating decimal. Understood? You take one more example and check out here. 5 by 13. Can 13 be expressed in the form of 2 to the power of 5 to the power of n? No. 13 cannot be expressed in this form. This 13 denominator cannot be expressed in 2 to the power of m into 5 to the power of n. So this cannot be a terminating decimal. It is a non-terminating decimal. Got it? Yes. Then one more thing, children. So small 2 questions will be asked by me for you. So if you answer this question, I'll be taking your name in my next YouTube video. So first question is 0 a rational number? And 1 by 81 is a terminating or non-terminating? Terminating or non-terminating? So try and comment so that I can take your name in my video and give a round of applause for you in my video. Hope you understood today's video. Then tomorrow we shall be entering into our topic real numbers. Thank you. Have a nice day. And yes, children, please don't forget to subscribe, like and also share. So as I'm doing with a lot of hard work these videos, it's almost all nearly like 1:30, 2 o'clock in the night. Hope you all like my videos. Please do subscribe, share, like and also comment so that I feel very energized. Hope you understood. Thank you. Have a nice day.